which is function operations. Do you know what operations are in math? Plus, minus, times, divided by, right? So those are the 4 operations that we're going to do today with a function, though, with like an f of x situation, okay? So here are our 4 operations. For the first one, it will look like this. Okay, you say that f plus g of x, okay? F plus g of x. Remember we said like f of x with the f and the x is in parentheses? This is f plus g of x, okay? The way you do addition is you take f of x and you add to it g of x, okay? So if you see this is actually what you're going to do. And it'll make more sense as I give you numbers, but that's your first operation, okay? So that's addition. We'll just do that. Subtraction, okay, if you're going to do subtraction, it's going to look like this. F minus g of x. And again, what you're going to do is, can you tell that's separated? Sorry, my line looks like it just kept going, huh? Do you see, can you see that's f minus g? You okay there? Okay. So what that actually is going to be is f of x, and you're going to take away g of x. Okay? So that's subtraction. You have to do it in that order. Why? Subtraction is not commutative, right? Commutative property says with addition, you can add in either order. Subtraction, you cannot. It has to be in that order. Third one is multiplication. And this one looks like this. It'll be fg of x, which is really just saying my f of x times my g of x. Oh, what should our last color be? Blue. We'll go blue. And then division. Okay, your division is going to look like this. F over g of x, which is basically saying take your f of x and divide by your g of x. With this one, there will be restrictions. Do you know why there will be restrictions? Right, g of x cannot equal 0, okay? So just be aware that when you do division, you might have to specify some restrictions, okay? Just kind of depends how your problem ends up. Okay, so here's what we're gonna do. We're gonna do a little bit of all of this, starting with example 1, and I'm gonna give you an f of x and a g of x, and we're gonna use it for several different problems, so you're not constantly having to write a new function down, okay? So we're gonna use these functions, f of x equals x squared minus 1, and g of x equals x plus 1. Okay, we're going to use those 2 functions for these next 4 problems that I do. Okay? First one. Let's say I tell you we want to do f plus g of x. Okay? We're adding the 2 functions together. Well, here's function number 1, here's function number 2, right? We're going to just add those 2 together. So it's going to look like this. X squared minus 1 plus x plus 1. Now, if there's something you can simplify in that, you simplify. If there's nothing to simplify, you're done. Is there something you can simplify here? Yes, we can combine our -1 and our +1, right? So it's x squared. We want to put it in standard form so that x would come next. And then if there's a number, you can put your constant behind that, but -1 plus 1 is 0. So this would just be your answer. X squared plus x, okay? Addition, you're just adding the 2 functions together. Questions on that? Pretty basic, hopefully. All right, let's subtract them. We're going to do f minus g of x. Okay, and this one you really have to be careful with because a lot of times people forget with subtraction that the distributive property might come into play. So if I'm subtracting f of x minus g of x, I'm doing x squared minus 1, that's my f of x, and I'm subtracting x plus 1. But where you need to be careful is we are subtracting the whole thing. Sorry, x plus 1, not x minus 1. Okay? And here's where a lot of mistakes get made because people will say x squared minus x and then negative 1 plus 1 goes away and we get the same answer as the last one, but we don't. You have to distribute that minus to both of these things. Okay, so really if you want to rewrite it, you could rewrite it x squared minus 1 minus x minus 1. And that simplified is going to give you x squared minus x minus 2. You with me on that? All right, third one. I should have kept my colors the same, huh? I didn't pay attention to what colors I used for what symbol. How about this one? We're going to do f times g of x. So we're multiplying our two functions together. Something I didn't say to begin, if you look up here, sometimes you're going to put parentheses around these. You're welcome to put parentheses around them every time. With addition, you don't really need it. A lot of times up here, people will be tempted to FOIL. But remember, there's a plus symbol in between. We don't want to FOIL. Where we do want to FOIL is what we do right now. Okay? F times g of x is going to look like this. We're going to take f of x, x squared minus 1, and multiply it by g of x, which is x plus 1. And now we're going to FOIL that. What's x squared times x? X cubed. X squared times 1 is just x squared. Negative 1 times x is minus x. And negative 1 times 1, you're leaving. Sorry, I lost my place. Negative 1 times 1 would be minus 1. Okay. Anything you can simplify there? Nope, that's your answer. You would leave it just like that. Okay. Questions on that? All right, let's divide. Did I do it in the same order? Oh, so close. I didn't. Okay, so still using those same two functions, okay? We're going to do f divided by g of x, okay? So that means on top, you have x squared minus 1. On bottom, you have x plus 1. We're dividing them, okay? Now, it's tempting right now for people to go, oh, you have a 1 over a 1. Let's get rid of that. And you have x squared over x. Let's just make that an x on top. But x squared minus 1 and x plus 1, those are factors. You can't just get rid of part of it. It's a unit, okay? So instead, what you're going to do is you're going to try to factor, if you can. Anyone remember what x squared minus 1 factors to? Right. That's the x plus 1 times x minus 1. It's a difference of two squares, right? Remember that? Wasn't that long ago that we did that, right? Should be fresh-ish. So that's going to be your numerator. Your denominator is x plus 1. Now you can cancel some things out because this x plus 1 and x plus 1, when you put them over top of each other, equal what? 1, right? X plus 1 over x plus 1. Any number over itself is 1. So this will reduce to 1, which means our answer is just x minus 1. You see that? Okay. So just be careful. Try to factor it first. Don't just start canceling out numbers that look like they're the same number. You can't do that when it's a binomial like that. So far, so good? You with me? Yes? Okay. second example, I'm going to give you some new functions now. Example number 2. We're going to say f of x is 2x plus 1, and g of x is x plus 5. Okay, so those are your functions. Let's say I want to do f divided by g of x. Okay, so we're going to divide them. How do you set that up? What goes on top? 2x plus 1. What goes on bottom? X plus 5. Right. Okay. Is there anything you can simplify here? Is there anything you can factor something out? Nothing. That is your answer. Isn't that lovely? You don't even have to do any work. The only difference, the only thing you do have to do is you do have to name restrictions if there are any. Is there a restriction here? X can't equal what? -5. We cannot have that equaling 0. So basically what you're checking for is when will that equal 0? Well, if you subtract 5, x equaling -5 would make it 0. So this is your restriction. Okay, but your answer, you didn't have to do anything to. It was just set it up. Okay? Questions on that?
So when you write that, do you have to put the x doesn't equal -5?
Yes. Yeah. Okay, now we're going to get a little fancier. We're going to do what's called a composition of functions. If you think back to geometry, you did composition of reflections in geometry. This is different, but same idea. A composition of functions is basically saying we're going to do two different functions together. So what it will look like is f of g of x, which is the same as f of g of x. I feel like people typically like that second notation better. Basically, you're doing something with a function and then taking that answer and putting it into another function and taking that answer, and that will be your final answer. So it might feel like you're going to get two answers here. It's not two answers. It's one answer. It's the final answer, okay? This, we would say f of g of x, if that helps you with the notation of it. Okay. So when you do this, okay, if this was our setup, your first step would be to evaluate g of x. Okay, if you think of how math typically works, when there's parentheses involved, we start on the inside and we work our way out. Okay, that's the same with this. We don't want to start with f of x. We want to start evaluating g of x. And once we know what g of x is, we can take that and use it to evaluate f of x, okay? Which might not make any sense to you right now, and that's okay, because I'm going to show you how to do it. Step 2, evaluate g of x. Step 2, you'll say with that answer, you're going to evaluate f of x. Okay, if it's in the order that you see up above there. Okay, so I'm going to give you two new functions again, and we're going to do this process. Example number 3. So here are your functions. Function number 1 is going to be f of x equals x minus 2. Okay, function number 2 is going to be g of x equals x squared. Okay, now I'm going to show you this two different ways, because it can be that f of x is on the inside or it could be g of x is on the inside. You just need to pay attention to which is which to see how you're going to set it up for yourself. So this first one, what we're going to do is f of g of 3. Okay, f of g of 3. What that means is we are taking 3 and plugging it into our g function. Okay, so that's where you're going to start. You're going to start by evaluating that inside function. So if I do that, g of 3 is 3 squared. So what is g of 3? G of 3 is 9. Okay, now with that answer, we're going to take this 9 and we're going to evaluate it in f of x, because we're saying f of g of x. So f of g of 3 here, that 9 is going to go here, and we're going to say f of 9 equals 9 minus 2, and I get 7 for that. That number is my answer, okay? F of g of 3 is equal to 7. Does that make sense? So plug in g of 3, plug in what you get from that into your f function, and you'll get your final answer. Good? Okay. What if we switch that? What if for letter B here, we do g of f of 8? Okay, we're going to use the same functions, but do g of f of 8. What are you going to do first? 8 into f of x, right? You're going to go f of 8 is 8 minus 2. So f of 8 is 6, okay? Mrs. Price says it's like laundry. You put the clothes in the washing machine, they come out wet, right? Here's our wet laundry. We need to put it in the dryer still. Put it in your other function, dry it off, okay? So we're gonna plug that 6 into our g of x. So it's gonna be g of 6 equals what? 36. It's 6 squared, right? So g of 6 is 36, which means that no, I did that backwards. G of f of 8 is equal to 36, okay? I don't need you to rewrite that every time. I'm just showing you what your final answer is, okay? 36 would be your final answer here. Questions on that? Okay, next one. Letter C. Let's do f of g of -4, or just so that you see the other notation here, it would be f of g of -4. It always looks like fog. I think that is maybe why people don't like it as much too. So f of g of -4. So we're going to plug in to which function first? G. Okay, so we're plugging a -4 into g. So g of -4 is, what is that equal to? Positive 16. Good. It's -4 squared. Don't forget the parentheses. So g of -4 is 16. Okay, now you'll plug that into f of x. So f of 16 is going to be 16 minus 2, which is 14, and that is your answer. Okay? Is this making sense? Getting it? All right, last one of these, and then we're going to throw some variables in the mix. Because who doesn't love a good variable, right? How about this one? G of 3. So there is no f here, right? We're using that g of x function twice, which is totally fine. You can absolutely do that. So I lost my functions. G of x is x squared. Okay, so we're saying g of 3 is 3 squared. So g of 3 is 9. What's g of 3? 81, right? You're going to take that number and square it. So your answer should be 81. Okay? right, I got 4 more little problems for you. 2 big ideas here. We're going to add some variables to these ones. Okay. Let's say our functions, this is example 4. Our functions are f of x, which is x plus 3, and g of x, which is 2x. Okay. Here's what we're going to do. For this first one, we're going to use those 2 functions for these next 2. So for this first one, using those 2 functions, I want to know what f of g of x is. Okay, notice I didn't give you a number to plug in for x. I gave you just the variable to plug in for x. So what's happening with this one is we're going to put our g of x in to f of x. Okay, so we're putting g of x into f of x, which means I'm taking this g of x and I'm plugging that in place of my x in f of x. Does that make sense? So when you do that, we get 2x, we'll put it here, 2x plus 3. And there's nothing else you can do with that. There's no simplifying needed. So that would be your answer. Okay. What if we switched that? What if I did g of f of x? Okay, so now I'm going to put my f of x into my g of x. Now here's where you have to be a little bit careful. F of x is x plus 3. Why would I need to be careful plugging that into g of x? You got to multiply. You have to distribute, okay? So if I plug that in, it's going to be 2 times x plus 3, and we're just going to distribute that. So 2x plus 6, and that's as simple as we can go with it. We don't have a value for x, so that would be your answer. Okay, so we're not plugging a number in, we're plugging in with variables now. Okay? Last one. Well, 2 problems, but using this last function setup. Example 5. Our functions are f of x, which is x squared plus 1, and g of x, which is x plus 3. Okay. And these ones get a little fancier. Here's what we want. I want f of g of x. Okay. Again, if you like the other notation better, you're always welcome to rewrite it like this. If that helps you to think through what your order would be, that's fine. But sometimes you're going to see it in this kind of like fog way. What one happens first? The g of x, okay? So we're taking g of x and we're putting it into f of x. Okay, now you have to be a little careful on this one, because if I'm taking this and plugging it in here, I need to square that binomial. Okay, so it's going to be x plus 3 squared plus 1. How do you do x plus 3 squared? You FOIL it. Okay, so make sure you FOIL x plus 3 times x plus 3. Don't forget about your plus 1 at the end. Okay, so when you FOIL this, anyone remember the shortcut to this? Yeah.
You square the first term, the first number, and the second number, and then the middle term will be the first and second number added together, and you multiply by 2.
Times 2. You're multiplying first, second, and 2. Yes, multiply all of them. So if you remember the shortcut on something like this, go ahead and use it. If you don't, just FOIL it. It would be x squared plus 3x plus 3x plus 9, And then don't forget about your plus 1 at the end, okay? So this would be x squared plus 6x plus 10, okay? So we just took our g and put it into our f, and we got that. So this is f of g of x, fog x. That's what it looks like. It's not, actually. We're going to switch that. Let's do it the other way. Let's say we're doing g of f of x. Okay, so now instead we're going to put our f of x into our g of x, which in this case is much simpler. What's that going to look like? We have to put f into g. Just give me initial setup. I'm not saying simplify anything. How is it going to read? We have to put this into this. X squared plus 1 plus 3, right? And then you can simplify that. X squared plus 4 would be your answer. Okay? Lots of F's and G's and X's. There's other letters too. It'll say like H of X, or you can use any letter as your G of, F of, all of that. F and G are the most common. You'll see some H's. Yeah. Questions?